Welcome back, Geometry Advanced. I hope you're all doing well. We are going to cover section 8.6. This section really just kind of wraps up everything we've been doing. So our objective is to identify special quadrilaterals. Really, we're just going to look at all the properties that we've talked about and see what quadrilaterals they apply to. So there's really nothing new in this section. We're just kind of wrapping it all up. For our warm-up, hopefully you would recognize this as a trapezoid. Technically, we should have those parallel marks on one pair of sides. So our goal is to solve for x. We are shown the mid segment here. Okay, we know that because these congruent marks mean that over here we have a midpoint. Same thing, over here we have a midpoint, so that is the mid segment. The mid segment is equal to 1/2 times the sum of the bases. So we'll just plug in the expressions they gave us. 4x minus 6 is equal to 1/2 times 3x plus 4 plus 7x minus 17. We can clean this up a little bit. Combine like terms in those parentheses. We would have 10x minus 13. If you watched my solutions video for the trapezoids and kites Google form, you'd know that I prefer to multiply both sides by 2 instead of distributing the 1/2. So when I do that, on the left side, I have 8x minus 12. On the right side, the 2 and the 1/2 kind of cancel out or multiply to be 1. So we're really just left with 10x minus 13. All right, from there I would recommend subtracting 8x on both sides so that your x stays positive, which would mean we would need to add 13 on both sides. Okay, when we do that, we would get 1 equals 2x, and then divide both sides by 2. X is equal to 1/2. Now, even though this works out mathematically, even if we plug it back in, I don't love this problem because technically this x is going to give us negative values for some of our sides. So this x value isn't super realistic. However, mathematically it works out, so we'll just kind of let it go for this one. All right, so here is a great summary of a lot of what we've talked about in this chapter. So we've got this quadrilateral family tree. You can find versions of this or possibly even the same family tree if you do a Google search for something like quadrilateral family tree or quadrilateral chart. It'll show you that we start off with a generic or general quadrilateral, and then we can classify it based on how many parallel lines there are. If you just have 2 parallel lines, meaning one pair of them, put this in there, one pair of parallel lines, then you're going to have a trapezoid. It could just be a generic trapezoid, or if you have that pair of congruent legs, then it could be an isosceles trapezoid. If you have 2 pairs of parallel lines, you've got a parallelogram. If it's a parallelogram, it could potentially be a rhombus or a rectangle. If it's both a rhombus and a rectangle at the same time, that's when you have a square. The last one we talked about is if there are no parallel sides, that's when you have a kite, which of course a kite has its own special properties. All right, so if you want to, you could pause the video, take a screenshot of this, and copy it into some notes in a document, or jot this down if you're taking your notes on paper. Do a Google search to find something similar, whatever works for you. So we've got a few examples today. We are mostly just going to be classifying different types of quadrilaterals based on information given to us. So quadrilateral ABCD has both pairs of opposite sides congruent. What type of quadrilateral or types of quadrilaterals meet this condition? So it could be type or types. So opposite sides congruent, both pairs, opposite sides congruent. Well, that was on our list for parallelograms, you might remember. That was one of our parallelogram properties. So because that's a property of parallelograms, it's a property of every type of parallelogram. So that includes rhombuses, rectangles, and squares. So these are all possibilities. This would not apply for a trapezoid. For a trapezoid, we never have a situation where both pairs of opposite sides are congruent. Also, this would not apply to a kite. In a kite, you have adjacent sides congruent, not opposite sides. All right. Example 2, what is the most specific name for the quadrilateral pictured? So quadrilateral, it's got 4 sides. We have to decide if this would fall under the trapezoid, parallelogram, or kite. So we are told that all the sides are congruent. If all the sides are congruent, that means opposite sides are congruent. So if opposite sides are congruent, it is a parallelogram. And because all 4 sides are congruent, it would qualify to be a rhombus. So then we just have to decide, can we then call it a square? Well, no, in this case we cannot call it a square because we don't have right angles. They didn't mark those for us. So the most specific name we can give would be to call it a rhombus. We could prove that it's a parallelogram, and because all sides are congruent, it's a rhombus. Example 3, is there enough information given in the diagram to show that quadrilateral PQRS is an isosceles trapezoid? Explain. All right, so in an isosceles trapezoid, we would need our base angles to be congruent. Okay, so one thing we do know is that PS and QR definitely are parallel to each other because these consecutive interior angles are supplementary. Those would add up to 180. So we do know that it's a trapezoid for sure. Then the next part would be to say if it's an isosceles trapezoid. So we know it's a trapezoid. Because consecutive interior angles are supplementary. Okay, so then we have to decide if it fits isosceles. So that goes back to the base angles. We have one pair of base angles congruent at P and S. Remember, the bases are the lines that are parallel. So we just need to know what this last angle at Q is going to be. To really be able to say that your base angles are congruent. You could do this a couple different ways. One way you could do it is to take the sum of all the angles inside of a quadrilateral, which would be 360, and subtract the angles that you know. And if you do that, you should get 106 degrees for the measure of angle Q. So if that's the case, then both pairs of base angles are congruent, so it is isosceles. All right, so I just got it written out. Yes, it's an isosceles trapezoid because both pairs of base angles are congruent. Okay, if you've got questions about any of these properties, you can revisit your notes, rewatch the other videos, email me questions, anything to help you out. Got a couple more examples. On example 4, what is the most specific name for quadrilateral ABCD? I'm hoping this one's fresh in your mind and pretty easy. We do not have opposite sides congruent to each other. We only have adjacent sides congruent to each other. Since opposite sides are not congruent, it is not a parallelogram or any type of parallelogram. We don't know if we have any parallel lines here. However, the property that we are given in those markings fits the description of a kite. So if you have adjacent sides, two pairs of adjacent sides congruent to each other, you should know that it's a kite. Okay, next. Is the diagram shown a rectangle? Explain. All right, so we've got a couple things to walk through. If this is going to be a rectangle, it needs to be a parallelogram, and it needs to have all 4 right angles. So let's start with the parallelogram part. Is this a parallelogram? I would say yes, this is a parallelogram because opposite sides are congruent. You have both pairs of opposite sides congruent, so it is a parallelogram. Then we need to know if it's a rectangle, meaning it would have all 4 right angles. Again, there are a couple ways to go about this. For one, this is a quadrilateral, so all these angles need to add up to 360. So you could take 360 minus 90, minus 90, minus 90. Or because we've already said that it's a parallelogram, you need to know that your opposite angles are congruent. Or that your consecutive angles are supplementary. Any way you go about it, E is going to have to be another right angle. So yes, it is a rectangle because it's a parallelogram with all right angles. All right. Next up, less of an example, more of an organization of some properties. So for each property that's listed, which this is not all of our properties, but for each one listed, we're going to mark if it's true for a parallelogram, rectangle, rhombus, square, kite, or trapezoid. Your homework assignment in a Google form tomorrow is going to be similar to this, where you have to identify which property fits with which quadrilateral. All right, so for which quadrilaterals are both pairs of opposite sides congruent? We've already talked about this one a little bit. Both pairs of opposite sides congruent is true for a parallelogram. If it's true for a parallelogram, it has to be true for each type of parallelogram. So that would be rhombus, rectangle, and square. Okay, that's not going to be true for a kite or a trapezoid. Both pairs of opposite angles are congruent. Again, that is one of our properties of a parallelogram, so it has to be true for every type of parallelogram. Exactly one pair of opposite sides congruent. Well, that's not going to be true for any of the parallelograms because we have both pairs of opposite sides congruent. That's not true for a kite because none of the opposite sides are congruent in a kite. So we're just left with a trapezoid. And if all it says is trapezoid, it doesn't say isosceles trapezoid, we don't know it for that either. So we can't mark any of these. If this said isosceles trapezoid, we could put a mark there, but it doesn't, so we can't. All right, we move on. Exactly one pair of opposite sides parallel. Well, again, that's not going to work for a parallelogram because we need both pairs for a parallelogram and every type of parallelogram. That's not true for a kite because on a kite we don't have any parallel sides. So that only works for a trapezoid. Only one pair of opposite parallel sides. Exactly one pair of opposite angles are congruent. Well, again, it's not going to work for any of our parallelograms because that would need both sides. In a kite, you do see exactly one pair of opposite angles congruent between the pairs of non-congruent sides. Again, that's not something you'll generally see in a trapezoid. Consecutive angles supplementary. So in this case, I would say any two consecutive angles are supplementary. That goes back to another property we talked about with parallelograms. If it's true for a generic parallelogram, it has to be true for a rectangle, a rhombus, and a square. It will not be true for a kite. For a trapezoid, based on the way it's worded, it's a little bit tricky. In a trapezoid, you'll have some consecutive angles that are supplementary, but not any two consecutive angles supplementary. So this one, I would maybe put like a half an X because of the way it's worded. Some of your consecutive angles are going to be supplementary. So you could put the word some there, but not all of them. All right, that wraps it up for today. So get your assignment for today completed. And then tomorrow's assignment will be along the same lines of practicing this. Next week, you'll get a chapter review to work on for a couple days. We'll be wrapping up chapter 8.